Okay, so third video, we are going to be looking at empirical formula. We have looked at this before, but if you see some of the exam questions are potentially a little bit tricky, so it's definitely worth another video. It always comes up as well. So the first question is quite standard. They're asking you to calculate the empirical formula. They tell you the mass of sodium, they tell you the mass of oxygen. So I draw my table and I put sodium and oxygen. Really important to remember here that even though oxygen is diatomic when it's an element, because in empirical formula questions it has reacted with something, in this case sodium, we never write it as O2. So it's O2 as an element, but in empirical formula questions you are always working out the formula of a compound, and so we don't write it as O2. Okay, so it's just Na and O. The mass you're given in the question, 0.92 of sodium, 0.32 of oxygen. Just make sure you put the right number with the right element. You're then dividing by these numbers here in the brackets, the atomic masses. Sodium is 23, oxygen is 16. Again, just double check that you've paired them up correctly. You divide and you get moles, 0.04 and 0.02. That gets you 1 mark. Next thing you need to do is get rid of the decimal places. You do that by dividing both numbers by the smallest number. 0.02 is smaller than 0.04, so you divide both of those numbers by 0.02. That allows you to get rid of the decimal. I've now got a 2 and I've got a 1. That gets me my second mark, and my final mark goes for writing this as a formula. The Na and the 2 go together, and the O and the 1 go together, and I get Na2O. So the most common mistake on this will be writing O as O2 and then putting 32 for the formula mass instead of just 16. Diatomic things doesn't apply with empirical formula because you're always dealing with compounds, never with elements. The next one is the same calculation, but they ask the question in a different way, so it's slightly less obvious that that's what they want you to do. Okay, so they give you 2 equations and they ask you to carry out a calculation to show which equation represents this reaction, and they give you numbers in the question. They give you 2.24 grams of iron, they give you 3.81 grams of copper, and they give you the relative atomic masses. Now, even if you've got no clue how to pick out the equation, do something with the numbers, don't just leave it blank. They've given you the same information as they had with empirical formula, so just go with that. Okay, so they've given you iron, they've given you copper, so I'm going to put iron and copper in my table. They've given me the mass of iron, they've given me the mass of copper, so I'm going to put that in. They've given me the atomic mass, so the Mr, so I'm going to put that in. Once I've got mass and I've got Mr, I can find moles. So I do 2.24 divided by 56 and 3.81 divided by 63.5. I then end up with these 2 numbers. Again, I'm going to try and get rid of my decimals, and to do that I look at the 2 numbers and ask myself which is smaller. It's 0.04, and I divide both of those numbers by 0.04. When I do that, I end up with this, 1 and 1.5. Now, we haven't gotten rid of the decimals, we still have a decimal, and no, you cannot just round up. So if you've got 0.5, 0.5 is a half. Just ask yourself how many halves are in a whole. The answer would be 2. Okay, so if I multiply 1.5 by 2, I have 2 halves, which is a whole, and that gets rid of the decimal for me. But if I'm multiplying this side by 2, I have to multiply this side by 2, and now I get a ratio of 2 is to 3. Now, at this point, you will have gotten 2 of your 3 marks from doing the same calculation above, but they're not asking you to write a formula. They don't want you to do this. Okay, A, that's not a thing. B, they're not asking you to calculate empirical formula, they're asking you which equation. So I've got the number 2 for iron, and I've got the number 3 for copper, and I need to come up here and look and see if I can figure out which equation they might be talking about. Well, if you look at equation 2, there's a big 2 in front of the Fe, and there's a big 3 in front of the copper. So the calculation that I have just done has given me the balancing numbers in the equation. I can then pick out equation 2 because those numbers match and they don't for equation 1. So it's the same calculation as what we did before, but it's a different question. So ultimately your final answer is picking the equation. So all you'd have to say now you've shown the calculation, you're just going to say it's equation 2. The next question is very similar. So ideally you'll press pause and you'll actually have a go at doing this for yourself, okay? But it's very, very similar. They give you 2 equations, they give you some numbers, they want to know which is which, and they've given you the same information: a mass, a formula mass, and a formula mass, okay? So press pause, have a go for yourself first, and then press play to see the answers. Alright, hopefully you've had a go at this. Alright, you have got 4.48 for iron and 24.84 for lead. Alright, again, just make sure that you are putting those numbers in the right place. You're dividing by 56 and by 207, and you should get 0.08 for iron and 0.12 for lead. That gets you your first mark. To get rid of these decimals, you divide across by the smallest. 0.8 is smaller than 1.2, so I divide both of them by 0.8. And when I do that, I get 1 and 1.5. So just as we saw before, if you end up with 0.5, you cannot round up. You multiply both sides by 2, and you end up again with 2:3. At this point, I've got a 2 for iron, and I've got a 3 for lead, and I need to pick out the equation. You can see, just like we had before, you've got a big 2 in front of the FE and a big 3 in front of the PB, and that means it's going to be equation 2. So I just need to write equation 2 at the end. I've shown why from my calculation. Now the next question, again, looks very similar. They're giving you the mass of phosphorus, the mass of oxygen. They also give you other information, and if you look at the very end, they don't ask you to calculate empirical formula, they ask you to calculate molecular formula. Now again, even if you're like, I don't know the difference, I don't know what that means, because they've given you grams and they've given you atomic mass, you can find moles. Alright, if in doubt, just find moles, okay? So I've got my phosphorus, P, and I've got my oxygen, O. Again, oxygen's not diatomic because it's reacted with phosphorus. So I've got the mass of each, 1.24 and 1.6. I've got my formula mass, 31 for phosphorus, 16 for oxygen, and I find moles. Alright, mass divided by formula mass is going to be moles, and that gets me my first mark. Then I simplify the ratio, 0.04, okay, because that 0 is there, it makes it the smaller number, so I divide both of them by 0.04, and I get 1 and 2.5. So again, I've got a 0.5. To get rid of it, I don't round up, I multiply everything by 2, and I get 2 and 5, okay? Now at this point, there's no equations or anything for me to link it to, so at this point I'm going to do what I did previously, when there was no equations, and I'm going to write it as an empirical formula. P2O5, and that gets me my second mark. Okay, now this is what we call the empirical formula, but you're asked for the molecular formula. Now you may ask, what's the difference? Okay, if I give you the molecular formula of glucose, C6H12O6, that tells me exactly how many atoms I have in a glucose molecule. If I give you empirical formula, what I need to do is I need to simplify this formula to the simplest whole number ratio. And to do that, I just look at the numbers that I've got, 6, 12, and 6, and ask myself, what's the biggest number that divides in evenly to all numbers? And the biggest number that it goes evenly is 6. So if I divide all of these numbers by 6, I get C1H2O1, and this is now the empirical formula. So molecular showed me the actual number of atoms in glucose. Empirical, I just simplified the ratio and got CH2O. It still shows me that I've got the same number of carbon and oxygens, and I've got twice the number of hydrogens, which is what I've got in the real thing. Now what we've done so far in this question is we found the empirical formula. We found the simplest whole number ratio, but we need to get back to the molecular and work out how many phosphorus and how many oxygens I have. The ratio will stay the same, but these numbers are going to change. And to do this, you follow 3 steps. Okay, 3 steps. Step 1, you find the MR of the empirical formula. So it's the MR of P2O5. Now to do that, I'm going to be using these numbers here. It's 31 times 2 for phosphorus, and it's 16 times 5 for oxygen. So I'm just going to work out the formula. 31 times 2 plus 16 times 5 is 142. Okay, so that is step 1. In step 2, they're going to give you another number in the question, the relative formula mass of the entire molecule. And you're going to take that number from the question, 284, and you divide by your answer to step 1. You end up with an answer of 2. Your step 3, you take your answer for step 2 and you multiply it by the empirical formula, P2O5. You end up with 2 times 2 is 4, P4, 2 times 5 is 10, O10. Now I appreciate that seems quite long. Sometimes in these questions they give you the empirical formula and all you have to do is follow the 3 steps. This question's tricky because you had to calculate empirical formula first, then you had to follow the 3 steps. But if you learn the 3 steps, it's actually fine. All you're doing is calculating relative formula mass, which we do know how to do. Then you take the number in the question, okay, the number that doesn't have any units, okay, and you divide by your answer to step 1, and then you multiply the formula by your answer to step 2, okay. This part gets you 2 marks, this part gets you the other 2 marks. It is a little bit tricky, but at least when you get a question like this, if you can calculate the empirical formula, you're getting half the marks. The rest of these questions all relate to combustion, so you're going to have a go at that for yourself, but I will just do, actually, this one here, now we'll see who actually watches my video. You can skip that one. I will do that with you later. I mean, realistically, I'll probably come back to it next year. Don't do that one. And then the final one, I'm going to let you balance that for yourself. I'm going to let you write that formula for yourself, but I will do this part with you. C. Write a full balance equation for the following word equation. Alright? So again, each time I do this, I consider everything separately. Chlorine is an element, Cl. It is diatomic, so I have to write it as Cl2. Potassium bromide, okay, that is a compound, and it's an ionic compound, which means I have to use charges. Potassium's in group 1, it's got a +1 charge. Bromine is in group 7, it's got a -1 charge. The charges cancel, so I don't need to drop and swap, I just write it as KBr. On the other side, I've got bromine. Bromine is an element, its symbol is Br, and it is diatomic. If it's in group 7, it's diatomic, so it's Br2. Potassium chloride is an ionic compound. I work it out using the charges. K is +1, it's in group 1. Cl is -1, it's in group 7. Again, the charges cancel, I get KCl. So I consider each thing separately, and I work out the formulas, and then at the end, then I balance. Okay, so I've got 2 chlorines on the left, there's only 1 chlorine on the right, I need to put in a big 2. Now I've got 2 potassiums on the right, there's only 1 on the left, I put in a big 2. Now I look at my bromines, 2 on the left, 2 on the right, this is now balanced, it gets you 3 marks.